Hello, welcome to another video. So here we're looking at implementing the RFC 867 daytime protocol. I think I might just do a quick like decrease of that volume. Yeah, you can't hear it, but I can, because I just thought I'd have something in my ears. Anyhow, looking at implementing this old RFC from 1983, which implements the daytime protocol, which basically all it does is spit out the daytime. Mine doesn't quite do that, the server, but potentially it will look something a bit more like that. But currently all it does is that, which we might get to why that is in a second. What I first would like to do is talk about, at the end of last episode, I actually was talking about how to basically make this printing to standard out a bit more concurrency friendly, because we are forking 15 times and we were trying to write all at the same time. So what I'd like to do is kind of talk about the STD atomics, which I was struggling to remember, but I have now kind of recalled what you need to do. But basically, what I'm doing here is what you would call a spin lock. What I could do is implement, I believe Futex would let me do it, but basically I want some way to pause until it is basically the state I want is right. Yeah. So what we need to do is we need to have a lock, and this lock has to be in a memory space that all the forks can kind of talk to. So what I've done is I've used mmap, which you can kind of throw all these different flags at. I was debating kind of wrapping this into a little macro that will do it for me. But pretty much is you have we have a bool, and it's appointed to a single bool, and we allocate enough space for that, and it is shared so we can access it from all the forks, and it is also anonymous. There's no file underneath. It's similar to malloc, except malloc would not handle the shared nature. You also can't get away with just static memory, because I believe that's still like per process that will be that memory and then that memory and that memory. Yeah, but if you do this mmap, you can do it. So what we do is we have this boolean, and we use this function atomic test and set, and we pass it the lock, and we basically say we want to acquire it. And what this is doing is it is going to atomically, so without like having any interleaving calls, so when one fork calls this, no other forks will be able to run any in-between code. So at the end of it, another fork can start running, but during it, no. All atomic, which is kind of cool. So this is normally what you would use like a mutex for, which, I don't know, I decided to go away with it. Potentially we could make it a futex and get away with this busy loop. But most of the time you don't actually have to wait. And like, can we perhaps even bring this all the way down there, and then we can waited to print LU times, and then we can weighted. So if we do something like this and do a little times, I've also added another thing because I found that the forks weren't, so I was basically saying go up until like I minus fork count, which ideally all of them will have a similar count, but here you can see that fork 0 did 5 things, fork 2 did 2, and fork 1 did 3, but everything else did not much. And when I say it doesn't actually wait in that busy loop, it does wait a bit, so potentially that could be a way to speed things up. But I think the route I'm going will steer away from that. But anyhow, so that's basically that, and so if we recall, we were getting like 10k in 0.8 seconds, so if we do 10k and do this num again, we can see it's slightly slower, but it was actually, maybe the cache just needed to warm up. I don't know, it's this weighted going outside of that may actually indirectly do it. Nah. What else have I done? Interesting. Anyhow, this is kind of going quickish, but I think I want to still see kind of how many times I did wait, and perhaps we can try and make that number a bit better, and that will perhaps speed things up. I suppose it was going quicker. So like we could get 1 million. So 100k, that's 100k, was like 7 seconds, and it looks like this will be about like 10, maybe 16 seconds. I'm recording a video now, so perhaps the other change I did was actually something that made a difference. So the other change was this fetching an ID. So if we, I suppose, can we maybe get before this? Might have a bit more debugging going on, but what I want is, yes, here. So if we do this, it do like a whole bunch of printing. I wonder if I can. I don't really want to touch it. What we can do is do that one, yeah, just hide it all. So it's still doing like a bunch of printing, but theoretically it's like not really doing anything with it. Potentially better would be to just pipe it to dev now. Yeah, I don't know. Maybe I do want to be back here wherever it was, and I mean, one thing I can do to test my assumption is do a git stash, which perhaps I will, because I do find it odd that the time has gone up like that. Haven't done much, but so if we do a git stash and run that and then do this again. 7 seconds for 100k. So get dash hop. I suppose this does kind of make sense because we're like doing a bunch of busy waits, I guess. So I guess I could look into this Futex business. There is like a Futex man page which gives like an example, and perhaps I'll use this one down here. So if we get this, it suggests that we have a little static so I'm just making the assumption that this is what's taking up the time. And like we could theoretically like collate how much time is spent in that loop. But yeah, so what I might do is, so how do we do this? It basically says that we want to wait on like a mutex, and it is some like we call it just UN32, so we have to have a UN32, and the so yeah, what I think I want to do is we can do like a no, not that. So I kind of want to define, what do I want to call this thing? And we kind of just want to pass it a variable. And in here we can just do something like this. Something like that, and then wow, false. So maybe we'll do this, and where do we put all these other defines? Something like here. So where do we call in map? So we can probably go map non-shared std outlook, and I think that will basically just do that, and we can also do last ID, and that will do that. And just to check that it's still kind of going alright, we might take that off, and then it's 1.5, yeah, so that's still about the same thing. So, what is the thing that it wanted us to get? We wanted to get, so up here we could perhaps even start it off. So it wanted to be a uint 32t, and this can be how Futex, std out Futex, something like that. And then down here when we're doing all this mapping, we can, golly, what should I call that? It was std out something as well, but it was a Futex, just so we know it is a Futex. And here we can do something like that. Cool. So, what did we want to do with this Futex? So we need to like set it originally to be available, I guess. So we want to set So here we want to set this to be 1. It is now locked and loaded. And then when we want to do, we want to wait on just the address, and then this wait on address does this thing. So I think I might actually copy paste this, but I might like clean it up a little. We didn't get the Futex, so I might get all of that. I don't know, put it here. Do something like that, and maybe one more, and no, let me do that, and do something like that. Something like that, and like and this is something like that. We don't need that comment. I kind of like having truths maybe a bit more clear on what it is. So here we do call it a Futex. I kind of want to just do that. So if we're comparing in exchange. So the compare exchange will compare against 1, and if it is 1, it will put 0 in. So it's kind of doing the opposite of the test set thing, which is why we had to set it to 1 to start with, because if it is 1, and I mean we could set this to be, in fact, well, maybe why not. So here we can have 0, and this can be something like that, and like when we do this, we don't set it. So when we get the map, it will automatically be cleared. So if we do this, then I don't really care about that comment. That's right. So int, I think I want to call this f, and like what's this error business? So I think I want to do something like p error Futex, and maybe something like that. I mean, this could potentially just be a macro, and then that could be a more friendly return, because like now it's just going to abort as soon as it can't get, which potentially is a good state. Right, so at that point there we don't have that. Now, is that because it's kind of weird that it called it a long, but the return is an int? Just saying. Cool. And so what was the like f post? We probably want to have that as well, but do something like that and that. Just have that. We don't need that. so this is Futex release. No, not that. That. And so here we are waking up all the Futexes. And here we, if we have a I think I might want to do that just so we can see where it is. So this is wait. So when we're waiting on it. So here we are doing the same. We're doing the compare exchange. So here we if it has one in it, so it's currently being used, we're sending it back to 0. Yeah, that kind of makes sense. And Futex, so the val, we probably want to set this to be something like that. Which is like the opposite of what it is. So that one there and that one there. Sorry for the flashbang, but yeah, the 0 there and the 0 there. Perfect. So at this point here, we could almost just get rid of that one. And here we actually just go Futex wait. So I guess we could do kind of a loop. So for do we have any breaks in here? We got a break there, which breaks out of that. So we can do like a cool loop. Futex. It's kind of like a defer, but not, I guess. So we would do a Futex wait on our Futex, and we didn't have to wait for anything there, did we? Futex wait. We just had to give it the thing, and so that's what we do there. And then here we want to continue while it's false. Is that kind of what we want to do? And then the increment, we want to go Futex. Something like this. I don't know if this is a good way of doing it. I'm just having a play around, I guess. Something like that. I wonder if they'll let me compile. Nah, so we needed some includes for this old thing, so I think it was just that one really. Did we so we don't have that. Alright, you're probably in here. Makes sense. here now. Right, so now we don't have to disable it. Well, like, potentially I want to do it a similar way. Maybe I want to do this. And then do something like that. So now we don't have SD out lock. So does this work? So we had like 10,000. Yeah, that's cool. It still gets this same 10,000. I can't recall. Get log has it 10k in 0.8 seconds. So that's similar time to what it was. But this is so to test, we should probably like test that, and like it's still doubling up. Interesting. So we're waiting for it to be 1 and then set it to 0, except we're like reversing that. So we're waiting for it to become 0 and then set it to 1. That's just the comment, perfect. So we want 0, then 1, and then down here we want 1, I believe, yeah. So 0 and 1, and then we want 1. And then down here we want to set it to 0. Well, we want to set it to, well, if it is 1, then we want to set it to 0. And then we want to do this also to 0. Perfect. Yeah, so I don't actually quite understand why this is doing this. So what I'm going to do is just add more printing to the mess. So we can do std error, and here we can have fork, and we can in critical, and perhaps that's all we need. And then when we releasing, and this should all be doing that. Maybe do it 10, maybe do it 100. There are like, we did not compile, did we? No, we didn't. Yes, that means fork ID needs to be there, and also fork ID needs to be there. So let's try and find a point where it doubles up. So here we have 1 is in critical, but 4 is also in critical. and 2 is also critical. Yeah, so that's not working. Oi. I kind of want to something like that is we're not allowed Futex, alright. Oh no, we do have a Futex there, but is that because we're not following follow forks? Yeah, so that's kind of what we want to do. Cool, so this must be a path 1. So we get 0 and that is already getting it. So here we are waiting on 1. And then fork 0 is releasing, so we're waiting it. And then this on 1 is now returned 0, but then that has returned 1, that's cool. Right, so we get EAGAIN. And if it gets to again, then we do that. Alright. So it's because this thing, whatever that is, no, we'll need a, can we, do something like that. This thing here, so it is true. Modify right, perfect. So if it was 0 and we set it to 1, then that will be true. And then if it's 1, but it is 1, so if that is true, perfect, then we will do the wake. like that. I don't know. I don't trust these Futexes. Let's just go for a nice little one. So I kind of want to know what it is after releasing. Yeah, I'm not too sure. Where's the bit where it prints multiple? I like how I just had a working thing, then mucked it all up. What am I doing? So I need to search for have something like that. Cool. So at this point here, both 2 and 9 think they're in critical. I don't get it. This after release equal 1 is interesting. After release. I mean, it can happen. It just seems odd. Man, this is quite frustrating that it was working, but now it is not. Do we want to do that? I think that's what we want to do. So we want to do a Futex op, and what op is that? We want to do a wake. So if it is equal to that, we are waiting. That's kind of what I'm seeing. It sleeps waiting for a Futex wait on that same thing. How much? No. Easy. Right, so when we wait, we actually want to wait one thing. So when we wait, we want to wait on the expected value and basically the close. So we want to wait while it is 1. So same. And then we want to wait at least 1, at most 1. Right, golly. So if we do a grid on, yep, and it did pop out with 2 dot star. Yeah, so that is still doing it. So, operation tested the value of the Futex word still contains the expected value, and if so, it then sleeps. So, if this has this value, which means that it is currently in use, we're going to wait. Yes. Cool. And when we wake, we want to wake up 1. Or do we just want to like wake up all of them? Alright, so we come in, we have a Futex, and we are going to compare the Futex against 0. So if it is currently not in use, we will then set it to 1. And if we were allowed to do that, then we break. So we've waited. Cool. Otherwise, we do a wait while it is 1, we do that. So here we do the opposite. So we have the lock. So we come in and we release it. So we check whether it is, well, we compare it against 1, and if it is the case, then we set it to 0. Perfect. Which means that it is now free to go. And here we do the Futex and we wake up as many as we can. Could have thundering heard if we do that, but so at that point there, one of these bad boys should be able to wake up. And am I calling this wrong? So we just have a Futex wait, and we do a release at the end. We now want to do like a not like that. Is that getting in the way? Like the ordering matters. 2, 1, and then just 1. I don't know. Maybe the ordering doesn't matter, and it'll just do whatever it wants. Anyway, what I kind of want to see is whether we get multiple things in the critical section. So we should get a critical release, critical release, critical release. Here it looks different. Critical, critical. Right, so now we have 2 in the critical. Why? Though, 1 is releasing. Though the release happens before, the print for the actual release happens before we do the thing. Though, I mean, theoretically it doesn't. Because we flush do something like that. And critical raise, critical. So I want to look for something that this bad boy here. So why do we get 2 in the critical section? I feel like I'm doing that thing, like just repeating myself over and over. It's annoying because I had a working solution. Just using the like the test and set. keep it in there. Like when does that happen? And it's not all of them. Like different numbers every time. Releasing. Cool. So never wants to do what I want to do. Anyhow, so here we have stuff that's multiple. So that must be 3. That must be 2. Compare I like this bad boy. Result of the comparison. So, if it was 1 already, this should be false. I don't want to try a thing. Is this nothing will run now? Nothing will run now. Alright. I think I can use this sort of thing as well. This is just feel like that does the same thing. Ugh. That one. So, how do we get here? Yeah, so I don't. This surely can't be atomic. Alright, if I do it the way it wants me to and has it a one base thing, what would I do to change things? So we would want 1 and then 0, 0. Okay, so here we would find 1. That will do the trick. Find 1 and do find 1 and replace with 0. Cool. And here we will also do 1 and call it that, and then this will be 1. Sure. It was this way, that one thing, but yeah, we can. Right, so now it is deadlocked because we haven't set it to anything. Still does it. It's just really bizarre. I kind of want an example with a fork and a Futex working together. Like, do you do a fork? So you do a fork, but you also do like shared memory like that, rather than doesn't actually have the little functions. Here we do. So So what happens if you do return? Yeah, I mean right. Mm. It's weird that they use two there and there for different meanings. I feel like this is it's locked and there's waiters in the lock, but you can't be sure that. Oh, I suppose like you are a waiter if you're in this loop, because cool. Feel like I need that heater back on. Course, of course. Sitting right there, can't do it. It connected. It's like more effort to turn it on because I don't know. There's no like actual switch. it just seems. This. If it's true, it does that. And if it's false, updates the content of the memory pointed to by expected with that pointed to by the object. So, 1 gets overridden to not 1. And this can just be 1. So I would expect that to always be 1. C, it is sometimes 0. So I think like this needs to just be like this, and well, in fact, we can potentially just go like that. And if we do a search for that, we don't have any lines like that. We could potentially bump it up, and we don't have any lines like that. Cool. That is fucking the voodoo magic. And like, the reason why I got that was reading through this source code, that comment was like, huh, yes, that does kind of make it a bit nicer that you kind of wrap it up in that. But yeah, we can just wrap it up like this. We don't really care about that anymore. I feel like this is unreachable, and we had an unreachable, didn't we? We had an unreachable here. And Futex value was already released. And that made that. And I believe this chucks in the new line for me. Perfect. So if that's the case, then this, we should be able to do like like something like this, except without that one thing. So we still have critical. And so I guess we should never have two criticals in a row. But anyhow, we will do something like that, and don't need to flush here for no reason every time. Oh, look at that. And so the weighting, I guess what we can do is actually return a size t of how much we weighted. Weighted equal 0, and here we can just go weighted plus plus, and here we can probably return weighted. And so when we do this, we can do something like that, and then it should hopefully say how many times we weighted, which I believe is less than previous times. So if we go like num equals 10, like that was, we get a couple of weights there. If we do 10k, we get 10k 0.8 seconds. So yeah, it's about what it was before, but it is good, and it's running the same thing. So this basically fixed a couple of bugs in the old version where we weren't really getting a last ID. I don't think I mentioned that, but I also get a last ID, which is a size t pointer to, and all we do is atomic fetch add, which will atomically get whatever it was and add 1 to it. And so each time this goes, each fork will pick up a unique ID. So they will kind of appear out of order. Who really cares? But it's basically the way that it goes. So this is doing this in some amount of time. If we do 100k, that was like 9 seconds. So I feel like we've gone back to where it was. Cool, and middle was a bit longer. So what was a mil was a minute 10 seconds. So I feel like it is slightly slower. This will kind of do some stuff. Before we weren't even doing the Futex weighting, so we can potentially simulate that by just like meh, whatevs. And maybe we can go back to the 10k. So now with that, we can run that again. Yeah, so that's getting slightly quicker, more like the speeds that we were seeing, 0.8. And this will be hopefully around 7 seconds, maybe 8 seconds. But this is a bit more accurate of what it was. So there we go, we get that. But if we do do like a less on like 1,000, we can see it is many times there are doubled up numbers like that. and now we don't. Cool. So what I might do is kind of just add up that add minus p. So this is just going to fix concurrency issue with printing to std out get ID uses shared memory mappings and Futexes to handle critical section of printing to std out. Cool. So that's that. I might just get rid of that one file. So that's that. Took a bit longer to kind of explain that than what I was thinking. But what I kind of want to do now is, well, actually, I want to. So this, if we go num, we can just. Commit minus amend. So if we do this, so 10k point 8 sec. And just to make sure we kind of keep our reporting somewhat accurate. So this is probably 8 seconds. And so this is 1 million and I mean, a bit over a minute. So I haven't really sped up that one, but I mentioned in the last episode that I would look at some potential improvements. So one potential improvement is like noting that we've had to kind of work in some concurrency control around output. So there's one thing that we kind of have to wait on, but not, I don't know, not fully have everything. So this is taking a bit longer than the minute I was thinking. Didn't actually check when I started, but whatevs. Oh, it's getting a little late actually. This feels like it's stalled, if I'm going to be honest. I think I might do a date at the start, just so we know when we kind of run things. So this was around 7 seconds. Potentially it was just about to go, but yeah, we'll try it again. So the thing I was going to work on now was make this non-blocking, ideally, or only block when we need to. It's interesting that it says waited to print 0 times every time. Source personal RFC, that one. And like in here we do that And we can potentially swap the Futex state from on to off as well. Yes, we have weighted there. Do we do the weighted there? Interesting. Right. So what are we now? We're alright. So we're actually a little bit slower. So maybe 1 20-second. And what was it before? Yeah, it's a little slower. Cool. So what I might do is, while we're in the mood of doing this, I kind of want to do this. I've gone into that mode. That keyboard, cool. So here we want to do 1, and here we also want to do 1. So if we do that, then we weight it plus plus, and here this is just going to be 1, and it's going to be that. And what do we want to do? We want to do that and find that. Do that. We want to wake up 1 still. And just to make sure that this still kind of runs in 8-ish seconds, just make sure that still does the right thing. It's in a deadlock, and that is because Futex. So when we do this one, we don't want to do that. So 7 to 8 seconds, hopefully. 9 seconds. Warm the caches up, maybe. It's interesting, it waits to print 0 times, and then lots of times there. So, just flicking it back to the other way, I guess that must have just been a bug. So if we do this, from the what we've kind of changed, that's pretty straightforward. Easy, and easy. So compile that. Easy. So if we do that, like, does it still wait on a crazy amount of times? The fact that it's waiting lots means there's contention, I guess. Anyhow, the next step would be perhaps keeping the forking, because I think from other tests I've done, forking does seem to speed up things quite significantly, even with the non-blocking mechanisms. this was going to be like a minute or so, wasn't it? So it's like coming up a minute. Anyway, so what we want to do is basically every time we connect a socket, we can make this in a non-blocking manner, and then kind of like add it to a set of things that we're going to wait for, I guess. Could be kind of interesting. Oh, this is taking ages. Minute and a half. Yeah, golly. Yeah, it's doing a few things. Old Futexes. So, what I kind of want to do, have we got this? Yeah, sure. It's roughly that. What I want to do is make it significantly quicker. So how we might do that is that heater went back on. It's getting chilly. My tooth is starting to hurt, so I might have to actually wrap up and head back into the house and golly, wrap up. The sun is dropping down. I've got the hood as well. So what I want to do is a minute to go. Basically, there's a syscall select, I guess, which is potentially quite useful to look at. Right, so we can only allow a certain number of things. So FD set size. And was that like it? Golly, that is just unreasonably low. So basically, we can only have 1024, which by default, this might be about right. Minus n. 1024 is the default open files, and so what was it? 1024. Yeah, this is potentially fine. So yeah, I won't make any long-lasting changes. So in connect socket, if we look at that, when we connect to the socket, we now want to kind of make it non-blocking, I guess. So if we look at socket and non-block, we can actually do it in connect, I think. Or is this just we do it when we create the socket? So this is just when we create the socket, and this is a type. So the type is the second argument. So in here we basically do pipe that with sock non-block. Simple as that. Now, if that, yeah, so if that is correct, we now kind of want to do kind of get that, and can we get there? And if C equals, so if C not equal to that, or so in connect, we can basically have return value, and it could be -1, and it potentially is -1. It most likely will be -1. What we want to do is look for some things. So if it is like this, then we want to do if error no equals e it's kind of annoying. Something like that, and we can also have E in progress. Or potentially even E is con. Nah, that's not really what we want to do. Here we probably want to do a break, and here we can do okay. If it's okay, then we break again. So basically, we might get in a state where the connection doesn't work, and we'll find as soon as we do this, it pretty much doesn't work. So if we go back to, I don't know, just doing something like 10 things, we can see like we got some results back, but we get some interesting. Like we hang. So because we're hanging, it kind of means I kind of thought that we need to wait until we're able to read, which I guess we did in this sense. But the read could what was this message it gave? Resource temporarily unavailable. So resource available. Error no minus L grep unavailable. So it would be one of these, EAGAIN or E would block. Perfect. This is what we want. And because we just crap out if it is a error. So what we can do is do a switch on error no, and if it is case E again, and we need to do a like weird thing. If E again not equal, don't do that. Not equal to E would block. We also want to do a case E would block. As you can see on my systems, they are the same, but they potentially might not be. Return, so E again or E would block. Perfect. Was there another one? That's perfect. So So if it is one of these things, we probably want to just do a break. Otherwise, we can do a default of that thing, and that's the case it is. Now, if it is the case, we probably want to just continue. We didn't read anything, and so we'll loop back up to when we can read. This is still kind of doing we're taking away the blocking nature and making it very busy in the sense, but we will change that at some point. So we might also have the similar issue here on right. So we need the other man page, this one. So here we can also have EAGAIN or E would block, and various other things. So what we probably want to do is just do that whole thing there, and chuck it in there. Can we do like something like that, and then that? Thanks. And here we can do right, and potentially. So this is. Oh, actually, we can just go continue here. The magic of and then we can probably just do something like that. So if it is the case, then we do that. Otherwise, we do something like that is what I want to do. So if it was that case, we could also have case E inter, and I feel like we probably want to do the same thing for that. So that's when a system call has interrupted my connection, and so perhaps in case E inter, in this case we don't really need it. If an interrupt call happen, we'll just go and do the whole thing again. Cool. Does this kind of run now? Cool, so this runs and we get 10. So we can probably try a num of, I don't know, 10k, and see if this goes. This is going. So I didn't really expect any change here. It's looking similar speeds. But we have now made it non-blocking. All we've done. We haven't actually got standard out being non-blocking, and I kind of want that to be the case. So I think you want to do set sock opt, and is that what we want to do? And then we want to do block. All right, so we need to look at socket. Not there. Well, we don't have a socket. This isn't a socket. We want. We just have a file descriptor. FCTNL, is that what I want to do? If control, that's what we want. Manipulate file descriptor. Cool. And here we can block. Do a blocking. So we need it fl. Alright, so here we need to go int fcntl, and what did it want me to do? File descriptor op. Arg is ignored. And what do we want on the fl? Get fl. So std out file number and memory man. If get fl. If get fl. And arg is ignored. Now, so if this returns -1, is that what the case is? FL value of that, -1 on return. So if FL equal -1, we probably want to go p error, fcntl get FL, and return defer, exit failure, perfect. And so if that is all the case, now we kind of want to do fcntl, we want to do it on the same file descriptor. Now we want to do set fl, and here we want to do fl or with whatever it was, keys here, block, so o underscore non-block, o non-block, and if we do that, and here if fl equal -1, that's the one, then we can probably do the same thing here, and that is set fl. Cool, so now standard out is also non-blocking. Cool, we don't have that, we need to include it. No, take me there, but take me there, and include fcntl file control, I believe it is. No, take me there, and yeah, that's the one I want, and sort that for me. Except find the define. Ugh, I hate getting tired. Alright, so now if we do this, we should theoretically be the same. All we've done is made things non-blocking. Slightly slower. And it's slightly slower because we're now busy looping for when we can write and whatnot. So what I kind of want to do is we need to do a select. Is no point reading while we can't do things. So we kind of need to store all our sockets that we kind of create. The problem is each file, each fork will have its own copy of every file descriptor. It has, you can't like, if I preemptively created a bunch in the parent process and connected, then it would work. And potentially that can work. Because we're allowed to go up to a certain size, I guess. So I guess here, soft fd is greater than, this had a, what was it, select, and we had fd set size. Fd set size if that is greater than that, then unreachable. We'll just do that. STE error sock FD too big, and we can just pass it sock FD FD something like that. Cool. So yeah, we just do something like that. So ideally this won't crap out. And this is with like 100,000 sockets, so it's creating one at the same time. So that looks good. We can make use of this. So what we want to do, what I might do is, don't do that, do something like this, and we can just kind of man this select here. So NFDs, we kind of have this FD set, but then like we kind of like we kind of change it every time. Do you have a little thing? We do this, we do that. Ooh, wait, it's not really doing anything with it. I really wish they would give a slightly bigger example, you know. But yeah, what I'm wondering is whether we can actually kind of so we need to do this in the fork. So after we have kind of made a child, so we can have an FD set, and perhaps we can just have it on the stack. Yeah, I kind of like that. Cool. So this can be readables, and we can kind of do something like writables, and we don't really care about the except, I guess. So here, what I kind of want to do is when we get the socket, we make sure that it's not too big, and then we do like an FD set of sock FD to readables. We want to wait until it is readable. And what did it say? It said can only monitor that are less than that. So I'm kind of wondering when to bail out. So we currently have so like how do we store that ID with things? I kind of want some memory or something, or like I don't know, a little. I have a little map I can make use of, which could be useful, because we need to. In the essence, we need to kind of make some memory and whatnot, and kind of tag things, because the problem with event-based stuff is you're not working linearly. So at the point that we create the socket, we need to be able to tag that somewhere. The EPOL system makes it a bit better because it provides a map, I guess. But this does not. So what I can do is yeah, like the sets must be reinitialized. Cool. So just trying to think the best way to kind of go about things. Something like that. Because we get this ID. So I'm wondering whether we need to kind of maybe do this and do like a type def of the struct and what's this structure got going on with it, and we're going to call this a connection T, I guess. So what has connection got going on with it? We have a file descriptor. We need one. Perhaps we should get an ID. So if we have that, is that all we need? I feel like that's all we kind of need, but we also need a place to store these. So I kind of want to make a arena. So what we can do is we can create another structure. I kind of want to make a kind of two things. So to avoid creating memory that we don't kind of use too much, what I want to do is I want to kind of make a connection free list. So this is going to be I'm just going to call it a list actually. And what it's going to have is it's going to have a connection T connection. So it's going to have a pointer to that, and it's also going to have a struct connection list T next. So it's just like a linked list, but this is going to be used for like a free list type thing. So this is going to be connection arena. Maybe we can do a minus T as well. So what the arena is going to do is, if we want ways to like free stuff afterwards, we will need to kind of keep track of that. So perhaps allocations. So in here we can have a size T capacity. Can't tab complete that. And then we can have a connection T. And we can have a pointer to a pointer. So basically an array of connection T pointers. But we can also have a maybe give this a name connection list T. We can also have a connection list t, and that can just be the free list. So basically, when we allocate something, we first try and allocate it from the free list, and we will also have a size and also a capacity, I guess. Now this capacity is actually different from that capacity. This capacity is like the like total capacity there is. So basically the amount, it will be the size plus the free list size in essence. Whereas the capacity up here is the capacity of this array of pointers, which will likely go up. Cool. So what do we want to do with this arena? We probably want a way to make a new connection new, and we will take in an arena. Now, so what is this going to do? So if we have a free list, well, if the arena, if arena equal null, we should probably just return a null. If the free list is null, then we need to do some allocations of, we will do some things. So, so we can have something like this. So we can probably go like this, and we kind of want to just cast it. So we're going to cast the arena free list as a thing, but like perhaps I'll connection list t free list equals arena free list. Want that one as well. Cool. So what we're going to do is free list. We're just going to call it a thing, but we also want to do something like arena. Oh no, this is what we want to do in this case. We also want to do arena free list is going to be equal to free list next, and do something like that. And we probably want to do like a mem set of ret. And we'll set 0 and we'll do a size of connection type t, something like that. Because up here we're going to do calloc, which will do a similar thing. So we probably want to do calloc. We're going to get one of them, and we're going to get a size of connection t. And if ret equal null, then we are probably just going to bail out. Well, we can just return null. Return null. Now, I also want to arena size equal plus plus. We have allocated. We've done one more, but we're also going to capacity plus plus here, because we've allocated a new thing. just what it is. So what I want to do now is I also want to make sure that arena allocations dot capacity so if this is more than that, then we need to do some re-allocing. So we want to do arena allocations dot data, and this is going to be a re-alloc of arena allocations dot data, and it's going to be size of a pointer, and we're going to times it by new cap. So size t new cap equals so I guess I want this to be arena type def struct and do something like this. Connection allocations, sure. Connection allocations. Allocations. Is that what I want? Yeah, and it'll just be part of it. I don't know what I was doing with that. I think I do just want to kind of keep it all as that. What I was wondering was, that's like not in a good place. So like every time I do a pointer dereference, it's like kind of taking a memory lookup. So potentially having this as a separate type def, I guess, and do something like that, and connections, allocations. It's really just a list, but so here we can go connection allocations equals arena allocations, and then here we can just have it as that, and if it is currently empty, then we're going to make it I don't know, a decent size. Well, we can only have up to 1024 at once, so I don't know. We can probably just do that. I don't know, as good as any. Otherwise, we will do allocations dot capacity times 2. And we'll just increment it. And so here we can do that, and we do need that pointer because we need to kind of store it back. And here we kind of also want to do arena allo. I wonder if I can just do this actually. this can be new cap. And if allocations.data equal null, then we probably want to return null. Like that's a bad thing if we get to this point. But if we get to this point, then I potentially want to do a free of rect. In fact, I wonder if I want to. That's good order. I'm kind of annoyed about the I don't know, extra little stuff I can't see down there. Anyhow, this will do that. So that is ensuring that we have enough space in that allocations array, and then what we can do is we want to do arena allocations arena size. I think that's what I want to do, or is it capacity? I think it's capacity. I think it is capacity I want to do at this point. And here we can just say it's rect. Because this doesn't make change of the capacity, but the connection is still there, and it's still something that potentially needs freeing. So what I can do is do something like this, arena free, and if we're going to free the entire arena, what we can do is first thing we do that, and then we just need to kind of loop this, so we can potentially get and we want to save that as a thing, so we can do something like this, size t capacity, and that's going to be arena capacity. So the arena allocator's capacity does go up higher, but we don't actually want to free everything in that. We just want to free what we have actually allocated. And really this realloc should be doing a mem set of allocations.data plus allocations.capacity, and that's going to do pointer arithmetic, so it's basically going to add on in increments of the pointer size, and we want to set a null byte, and we want to set it for this is where it's kind of annoying. We do pointer arithmetic in the first place, but we don't. I kind of want this to be size of allocations.data, but like a thing like that. The allocations.data. So we're going to get the size of each element, and then this is going to be new, we're going to times it by new cap minus allocations.capacity, which should set everything past what we have had as null. So we do that. Then we kind of just set everything right. And then we kind of set that in there. Cool. And so back in this free, what we want to do now is we can do a size equals 0. We are basically going all up into that capacity, I++. I do wonder whether having capacity as the same name is the right word. Like potentially allocated, but then like allocate allocations is a thing, but yeah, maybe allocated. Yeah, and then this would be like that, and then there will be that, and then it'll be clear why it's not being done there. And here we would have size t allocated. Sure, I wonder whether these should be up here maybe. I didn't really want to kick off a thing just straight away, but yeah, so in here we will just want to do a free arena allocations. Now, so we already have allocations dot data, and we can just do that. And I feel like we should potentially wrap that in. Not equal to null, do that, and if capacity if allocated is greater than allocations dot capacity, and I think this needs to be greater than equal. This is not a normal state, so this will be unreachable maybe. Allocated greater than capacity, allocations dot capacity. And like maybe I can just do like something like that, and do something like that. So that's like not a usual case. If it's null here, then that's also kind of unusual. In fact, yeah, it is kind of if we are equal to null, then I think I want to do unreachable there. Allocations dot data, and there's a LU. We don't need to care about that, and then this will just be an I. So we'll free all of that, and then we will free allocations dot data, and I think we should also check that allocations dot data equal null. We can just return. It's kind of uninitialized. Yeah, so if it's uninitialized, we'll do that. Otherwise, we need to free the actual array. Perfect. So that's that. Useless storage class and empty declaration. That is because I don't have that there. No, I just want something like this, and I don't need it to be a star. Cool. set we don't do, and that's an include string.h, I believe. Is neither an array or a thing allocated on the arena? Yes. Oh, yes. No, that is good. That is because we need to do dot data on that. Right, so something like that. Something like that. What's happening there? Like, I don't know. That. What are you up to, Vim? Are we like searching for? No. Why is? I don't get it. Right. So ID it didn't get because yeah, ID is like up there. I think for compilability, I kind of want to do this. Right, so return non-void, that is because we need to return ret. Now, if we want to free stuff, I think I want to kind of bring that over here. So if we want to free stuff, we will probably do connection free, and we need to pass in the arena. And like this is one potentially benefit over malloc and stuff is you have to pass in the arena every time that you want to make use of it. It's not just somewhere on the heap, it's where it is. But that's what it is. Right, so here we can have connection, and that's one of those, and then one of these, and one of these. And so if arena equal null or connection equal to null, then I'm just going to return. There's nothing I can do. At this point here, I kind of want to get a pointer to pointer to the free list, and if a free list actually we just want to make this a connection list, and of the connection I forgot how free lists work again. You don't need that. I also kind of want to do a static assert of size of connection list T is greater than or equal to size of connection T, because I'm not actually sure it is. Connection list T too small to fit connection T. Yeah, so that is the case. So like it needs a pointer. So like we can just kind of add something else in here, I guess. Oh wait. No, this is the wrong way around. So we want something like that, but maybe do that, and then not that one. So connection list T must be smaller. Something like that. Cool. This is because we need to say it is a thing. So we don't need a pointer to the connection because the thing itself is. So what we can do is just next is going to be arena, and this is going to just be whatever the free list is. Now at this point here, arena size should go down, and I think we can do some stuff. Size equal to 0. This is unreachable. Trying to free. An empty arena, something like that. Something like that. And our location should never really go down. I mean, we could make it go down. Right, so that's compiling and whatnot. I don't get why Vim has decided to do that on me. Because like we compile, we run it again in 10 seconds ish, and hopefully it gets the right answer. 10 seconds does roughly the right thing. Perfect. So at this point here, we have like connections. So I guess at this point here, I need to kind of create a connection object and add it to some sort of a map. Now I do actually have a map thing. I believe there should be something in here. So if we copy that here, we can kind of create a map of whatnot, and we initialize it with the like default quantity and like supply a hash function and equal function, and we can grow it. This could potentially get reused, so instead of doing calc we do the oh actually no, this is the growing. That's fine because that's like just a like linear array, but the put, when we do this, we could probably have an arena here, which potentially I might make a little note. This could be using an arena and do something like that. Fix me. So that is that. Anyhow, how do we use this map? If we go back to here, we can kind of just include it. So what we can do is we need to actually define a map implementation. Implementation, that one there, and then we want to include just map.h. So at that point here we can kind of have a map somewhere in our main, likely. So here we can have we need to define a structure for our map, and we're probably going to have a connection, so type def map struct. I believe that's kind of what I do, and we just give it the two things. So we're going to have like, what are we doing? We want to map something. We kind of just want to store these connections somewhere, but where do we want to store them? And like against what key? Or are we just wanting to store them in an array of some description? If we store them as there was saw. I guess what the thing that we're wanting to do is we are wanting to select against things after we kind of create. Well, we want to create a thing, so we in here we get an ID. We get an ID, so we kind of have a mapping of IDs to I don't know, it's kind of interesting because yeah, I guess it could be an ID to a file descriptor. Well, I guess the file descriptor, we do store the ID in there. Do we even want a map? Because theoretically, I think I might get rid of that, and I potentially might end this. Now it has dragged on a little long. But yeah, what we actually already have all the allocations kind of in a list. But like whether it would be valid or not, kind of depends on this, whether it's in a free list or not. Yeah, maybe I need to come back and think what I actually want my map to be in, but we've got the foundation pretty good here. So I think if we kind of run stuff, it still roughly kind of did the thing, other way things. Yeah, so it's still roughly same amount of time. Perfect. So we're at the point that all we need to do is kind of just rejig this into how do we do this? So basically every select call, we need to build these sets. And then after each set call, we need to go through the sets and then see if something is set. So I guess we need to have a file descriptor from that. So I guess here we would be looping over a mapping from file descriptor to a connection. I feel like I'm going back in circles, but yeah, we kind of need a loop over all of the things. And I think it would be best in a map or a set of some description, but yeah, maybe I'll make a set. Who knows? Cool. I think I'll leave that there, and let's have a look-see to see what we've actually done. We've kind of just made things ready for action. So I think I might actually split this up a little. Actually, do we still use Futex? We still do use Futex. Oh, fuck it, I'll just add it all. We do that, 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 we do that. So this is just going to be git commit. We're going to add types for connection, add types, type, and arena for connections, make sockets non-blocking, all ready for select. Cool. I'll leave that there. Thank you very much for watching along, and if you enjoyed this, let me know. Otherwise, I'll be back next time to make more progress on this and get some select. See if that improves things. Who knows, it might. Alright, see ya.